So in this video, I'm going to describe how to count, add, subtract, multiply, and divide significant figures. First off, the content and language objectives. The content objective is I can count, add, subtract, multiply, and divide using significant figures. The language objective is I can write my own explanation of the purpose of using significant figures. So first off, significant figures example. Why would you bother with significant figures? The example here says an average cup of coffee is around 200 milliliters. If you added one 0.05 milliliter drop of water, what's the total volume of liquid in the cup? If you'd answered 200.05 milliliters, that's not quite significant. What significant figures is all about is figuring out how confident you are in your measurements so you can give an accurate representation of how closely you're paying attention to your values. And so if you have a cup of coffee with about 200 milliliters of liquid in it, and you add 0.05 milliliters, you do not have in that cup 200.05 milliliters of liquid. You approximated that 200 milliliters much less carefully. You measured it much less carefully than that 0.05. If you see 200.05 milliliters, that gives you an indication that you very carefully measured all that liquid, when that's probably not the case. What numbers are significant? So when you look at significant figures, I just have the number here that looks really small right now, but you'll see in a second why it's so small, 0.004004500. And so some numbers that are significant, any non-zero numbers, so 1 through 9, are always significant. Any numbers that are trapped between non-zero numbers are going to be significant figures. Any numbers after a decimal, any zeros after a decimal at the end of a number are going to be significant because you wouldn't have bothered to put them there unless you measured that carefully. But some numbers are just there for cosmetic purposes. So the 0.00, those numbers are just there because they have to be to build that number. And again, just describing those, they're there because they have to be. If you were to write this number in scientific notation, you'd see that the non-significant numbers would disappear. Determining significant figures, here's just a description of how to do that. What's really important, though, is if you look at the second to bottom line here, the 1.5 times 10 to the fourth, if you were to write 15,000 in scientific notation, you do it as 1.5 times 10 to the fourth. Oftentimes, a cheat to get to how many significant figures you have is to write a number in scientific notation, and you'll see the non-significant, they're just there to build the number, zeros. They are the non-significant ones. So what I thought would be most helpful is to go through a bunch of problems. The first example we have here is 23.0000720. And so to look at the numbers and kind of break them into different pieces, the first numbers, the 2 and the 3, they are significant because they're non-zeros. The 4 zeros are trapped between the 23 and the 72 in the center there. They're significant because they're trapped, if that makes any sense. 7 and 2 are both significant because they're non-zeros. And the 0 at the end, it's only there because you bothered to measure to that level of precision. And so you have a total of 9 significant figures in this problem. Problem number 2, you have 0.00348. The first 3 numbers are not significant. They're just placeholder zeros. If I were to write this number out in scientific notation, it would be 3.48 times 10 to the negative third power. The 3, 4, and 8 are significant because they're non-zeros. And so you have a total of 3 significant figures. 38,000 is our third example. The 3 and the 8 are significant because they're non-zeros. The 0, 0, 0, they're just there because they're placeholders. So there are 2 total significant figures. The next thing we haven't talked about is how you add, subtract, multiply, and divide significant figures. And so we'll go through that right now. So first, for adding and subtracting, the same rules apply for adding and subtracting significant figures. What it says here in these directions is when adding or subtracting, round the number to the least number of decimal places. And so that's how it describes it. How I would go through and solve this sort of problem is I would write the numbers atop each other, keeping the place values in the same place. And so here you can see the 7 and the 2 are atop each other. These are both the ones place. The 2 and the 3, they're both in the 10th place, and they're right atop each other. And then what I like to do is I like to just solve whatever the answer might be, but then to worry about significant figures. And so what I do is I just draw lines through any of the values that are not significant for both numbers. And so you measured to the 10th place for the 127.2, but you measured much beyond that point for that 2.33402. And so if you didn't bother to measure to the 100th place for all of the numbers, then you shouldn't pretend that you have measured with that level of care for all of the numbers. And so what we have is 129.5, 129.5. There are a total of 4 significant figures in your answer. Multiplying and dividing is a little bit different, and I think those are even a little bit easier. It says when multiplying or dividing, round the answer to the least number of significant digits. This is the one that bothers people a little bit more. So if you take 283.5 times 10, first you need to figure out how many significant figures you have in each number. For 283.5, you have 4 significant figures. For 10, you just have 1 significant figure. And so what that means, and this is where it gets kind of weird and it doesn't feel right, your answer should only have 1 significant figure. Again, what I would do is I would just multiply those numbers out. 283.5 times 10 gives you 2,835. But your answer should only have 1 significant figure, since 10 only has 1 significant figure. So what's your answer? 3,000. And so that's where people get a little thrown. 283.5 times 10. In math class, absolutely 100%, your answer is 2,835. But in science, what you're also trying to do, in addition to just doing some math, is you're trying to relay how carefully you bothered to measure all of these different measurements, and you don't want to give a sense of false confidence in your numbers. That's the end of this video explaining how to count, add, subtract, multiply, and divide significant figures. If you have any questions, please feel free to stop by during homework help hours or period 1A. Thank you very much and have a great day.